we're going to do a PIV-NRT question. What does he mean by a PIV-NRT question? It's one where we've already established that we're going to do one set of conditions, and we're going to use PV equals nRT. We knew this from our last video because there's only one set of conditions here. And we're going to have to find the volume as indicated down here from this equation up here. Pi r squared h. Centimeters cubed is a good volume because I know centimeters cubed is the same as, and we have to remember this. This was from test 1, and I said you had to remember it forever. 1 centimeter cubed is the same as 1 milliliter. So if you've got centimeters cubed, you can go to liters real quick, because a centimeter cubed is 1,000th of a liter. Okay. So we're going to find volume in centimeters cubed. V equals pi r squared h. So we'll just do the steps numbered here. V equals 3. Now, so most calculators have a pi key, so you don't have to type in all these numbers. R squared is the radius squared, and I gave it to you in centimeters. You are welcome. You have to square it. A couple ways to do that on your calculator. There's a y to the power of x key, y to the x. So you type in 41.41 y to the x and then 2. That's one way to do it. Or 41.41 with a little caret and a 2, if you have that key. Okay? Those are just little hints. Pi r squared times height. Height better be in centimeters too. And it is 216.3 centimeters. And when we're done, this was just for this piece here, or this piece, the same piece right there. Okay. So I will pause. All right, ladies and gentlemen, we finally got an answer, and here it is. We took 3.14159, multiplied it by 41.41 squared times 216.3. We even found another way on our calculator. On my particular calculator, there's a key that has this on it, but I don't think a lot of calculators have a key with that on it. And there's the answer. And the units, please. Don't forget, we got centimeters with inside a parenthesis and squared times centimeters. Oh, that's centimeters cubed. And it says, I'm going to do step 2 right now. Step 2 is in black. I got to get rid of centimeters cubed and make it into liters based on this. Whatever you say about centimeters cubed, you say about milliliters, right? Which one's bigger, centimeter cubed or liter? Liter's the big one, you put a 1. 1,000 little centimeter cubes. So, you know, not fair, but I can do this. And I'm moving the decimal 1, 2, 3. Entirely unfair, I know. Oh, that didn't work out. There it is. It's really small though. And that's now what units, please? Liters. That's right. Beautiful. Okay. Did I move it 3 times? 1, 2, 3. I didn't do it right. Did I? I did do it right. Never mind. Okay. Step 3. Step 3, always Celsius to Kelvin. And that step's not going to be on the test. Ever. Celsius, Kelvin. Sorry, it's not on tests. Convert to liters. We did that. Centimeters to Kelvin. We got degrees Celsius to Kelvin. Why did I say centimeters? 3. We've got Kelvin equals 273 plus degree C. 273 plus Celsius was 2521. 29821. Big K. Grams to moles. Oh man, grams to moles. And he didn't tell us the steps to do that. Oh no, we never tell you the steps to do grams per mole. But your eyes always go over to the periodic table, don't they? You need a formula before you go over there. And I gave you a formula for acetylene, C2H2. So to do grams per mole, you always need FW. 2 times 12.01. Here's a reminder, C2H2 plus 2 times 1.008. Yep, there it is. That's 2.016 plus 2402, 26.036. Makes sense. Units for the periodic table, please. Always. Grams over moles. Yeah, thank you. Now I can do I'm doing step 4 right here since I'm over there. I've got 0.621 grams times 1 mole for every 26036 grams. And that's small. Yeah, that's pretty small. Well, if it was 1/10, it would be 2.6, and it's less than that.
0.02.
Yep.
385,159.
And units are now mole. And we decided earlier we're using the old PV equals nRT. So that was decided in activity 1. Which of those things is the one we are interested in for this question? We got to read this question. Which of those 5 things that I wrote is being asked for in today's question? Pressure. What would the pressure be? We need to reorganize PV equals nRT to get pressure by itself. So I think we're just dividing both sides by volume. So we're continuing our little step 5 discussion here. Copying the equation out as is, just showing our work. Times 1 over V times, and that simplifies to P equals nRT over green V. So these guys cancel. And we are ready. We have N, we have R, we have T. N was 0.02. 38519. Wow. I didn't give you R here, did I? Mean teacher. It's okay, I'll give you R. I copy that right? I hope so. 2385, 2385, 159. Let's see. We got an activity. I got to give you R. Yes. I'll put it right here. Given R equals, and I always give you the number and the units. Those units, trust me, are more important than anything. For students who are buying into the chemistry game that we play, When a teacher gives you a constant and it's got all those units, it tells you what units you need for this question. You need liters, you need atmospheres, you need moles, you need kelvins. Okay? And the steps are just reminding you that. Okay, so we're 0.0821. She said it, I didn't write it. There we go. 0.0821 liter atmospheres per mole Kelvin. And we've got our N, and I'm going to copy that, 0.0821 liter atmosphere mole Kelvin. 0.821 liter times atmospheres all over moles Kelvin. Moles are now a thing of the past. And we haven't even finished this thing. That's nRT. Better use Kelvin. What do we got? 298.21. 98.21. Big K. Also a thing of the past. Big K on top. And big K on the bottom. And we're going to divide by V. V we worked out a long time ago to be 1,165.24. I'm not going to use 400 sig figs. It was in black before. 1,165.243. Why not? That's a 5. And I will pause here and wait for answers. All right, we've got an answer. It was 0.000501146. We put the liters in the bottom. Liters are canceling liters. And happily, we are left with only atmospheres, which is a pressure, which is our answer. Let's look at our sig figs in the question, though. That's too many. 3 sig figs here, 4 everywhere else. I would just always, from now on, just least sig figs in the question. We always do. We very rarely do addition and subtraction, right? We're almost always multiplication and division. So for these kind of problems, sig figs go to the question. 3 sig for your answer. Hook me up with 3 sig figs, everybody. These are not significant. Leading zeros. First significant, 1. Second significant, 0. Third significant, 1. End of story. ATM. Highlight it. Zoom it out so our latecomers can get it. And that's all we got for this one. Oh, and then.